I want to go ahead and get started. So hello, everyone. Thank you so much for attending. Thank you for taking the time to join. And if you're watching this afterwards, thank you for watching the recording. So my name is Bonnie Griffin. I'm a taxonomy consultant at Enterprise Knowledge, and I will be helping moderate for a new thought leadership series that Enterprise Knowledge is kicking off. This is a webinar series, the Semantic Exchange. Each week, we'll be bringing on the author of a recent thought leadership piece and invite the audience to ask them questions. So, reminder, in addition to this series, as you may have seen, Enterprise Knowledge has an expansive knowledge base covering a range of topics, all related to semantics. So after our talk, please go ahead and check out our knowledge base to read some more. If you're here, there's a good chance that we have blogs or case studies that will be relevant to the work that you're doing now. So to just give you a brief idea of how this webinar will work, we're going to start by introducing our guest speaker today, Ben Cass, and then he'll take some time to walk us through his white paper. What is semantics and why does it matter? After that, we'll open up to questions. Now, please share your questions in the chat and I'll moderate those, direct those to Ben. We'd like to ask everyone to please stay muted so we can all hear Ben clearly. If we have follow-up questions for you about what you put in the chat, we may ask you to come off mute, but please just stick to mute for the meantime. Now, this meeting will be recorded, so if you have to hop off early, you can always watch the rest of the recording, or please share the recording with your colleagues if you think they might find it useful. Now, as for Ben Cass, he is a senior ontology consultant who engages with a variety of clients to help them define, implement, and manage user-focused semantic models. He is also the author of the white paper, What is Semantics and Why Does It Matter?, which he'll be sharing with us today. So take it away, Ben.
Yeah, thank you, Bonnie. Give me one moment to stop sharing the current screen and I will pull up the white paper once I can get to it. You have to give me just one moment.
No worries. And for those of you that are just joining, welcome to the webinar series. We're going to ask that everyone stay muted. And as you have questions, please put those in the chat. We'll be monitoring those and answering them as they come in once Ben is done introducing the white paper that we'll be talking about today. And go ahead and check out the link. That is where you can read through this white paper if you need a refresher or if you haven't read it yet.
Yeah, thank you, Bonnie. So this is the white paper that I'm going to be talking about today. What is semantics and why does it matter? A brief history behind this white paper. Within EK, within the field of knowledge management, as well as taxonomy, ontology, information science, there's a lot of discussion of semantics, a lot of vendors in this space selling what they call semantic solutions. But I was finding that as a field, we're often frustratingly vague on what exactly semantics means, besides, oh, this is a buzzword that sounds nice. This is something you want to have. And I was noticing too that clients that I was working with were asking, well, what does semantics mean? What are we talking about when we discuss semantics? So within this paper, semantics itself is a term that comes from philosophy, but when we're talking about semantics within the field of knowledge management, typically we are looking at data or content. This article does focus on data, and seeing, all right, what is the meaning and information that's contained within a piece of data, within a data set, a data source, and then how is that information encoded and interpreted? An example that I went with, since I think nearly everyone's familiar with, would be a table, so kind of like an Excel table or a CSV, wherein for a veterinary clinic, you might have this table on screen, where for patients, you have the name of the animal, the breed of the animal, what type of animal it is, for the information on when the animal visited the veterinary clinic, maybe why they visited, and a date. So within this, kind of some of the most basic data that you can imagine, how do we interpret, how do we understand what's in this? We look to the columns in this case. So I see breed, and breed here is representing that, okay, the function, the cells beneath this this header for breed are representing different breeds of animals. And if I go left in the table, I can see, all right, this is further information about whatever animal this record is about. Now, some of that is coming from just how we understand tables to be used implicitly, kind of our conventions of tables. And some of it is coming from looking at, all right, what does the column header here say, right? What is the further information associated with this? We could go a step further and have a README with this table, right? That would say, hey, within this table that you're about to look at, here are the columns, here are the options for sex, here is the format that date would come in terms of uh, month, day, year. Here are the possible reasons for visit. And in fact, reasons for visit are filled out on our website or are encoded from the doctor's notes after a visit, right? We're trying to look at all of the information associated with this data set, however small or however large, that helps us to understand and make use of it. We might not have as much, that might not seem as important if it's just a single table that you or I have created, right? Maybe I have a small table that checks, all right, what projects am I on? What were my hours this week on each project? And kind of what was the task or two that I did. But say that, okay, we use this in the library world sometimes, but like imagine you get hit by a bus. Hopefully that never happens. But if you have your wonderful tables and then you get hit by a bus and someone else needs to come in and use your wonderful tables, will they be able to look at it and understand, right? Are there abbreviations within these tables that may not make sense? Are there terms that are very ambiguous where it might not be totally clear what this means? Uh, are there formats that are more unusual? And while we've been talking about this for tables, it applies to all forms of data, right? You see this a lot with other forms of structured data. If anyone here ever engages with XML or JSON data, for example, whether it's like an XML data record for like metadata or just like kind of unstructured JSON information for maybe like customer accounts. There are typically going to be fields to say, hey, this is the definition of a property within your data set, JSON or otherwise. But so rarely are those fields actually filled out. So rarely do we have this additional semantics to describe our meaning and make it something that other humans can see and understand, and in fact, that other machines can see and understand. Just brief go through, this is a picture of my cat Katara. I now have another cat, Toffee, who unfortunately doesn't have any photos in this article, so I'll have to work on that for the future. But I think when we talk about semantics, it's important to not view semantics as something that is like a future hyper advanced state of like, oh, I won't reach semantics until I have the latest data catalog, until I have the latest taxonomy ontology tool, unless I have 5 different LLM agents all working in concert across the enterprise organization. Ultimately, semantics, trying to understand the meaning of the things we create or that other folks create or that machines, tools, technology creates, is a daily activity. It is the foundation for a lot of more advanced systems, which is one of the reasons why we care about it. But it's also the foundation for just kind of understanding and making use of information that you have at an organization. Okay, to kind of briefly go through the rest of the article, I go into what are some of the characteristics of great semantic data. This is something that I got from a book that I think is really excellent. If you're into modeling for data, Panos Alexopoulos' Semantic Modeling for Data. But we want our semantic data, or when we're looking at data semantics, we're really aiming to A, be explicit in what the meaning is. So not just, hey, I know what this is because I can assume based on name, right? If I go back up to my example here, we say name, animal, breed, but there's nothing here that says, well, is this the name of the animal that was the patient at the clinic, or is this the name of the person who brought in the animal to the clinic? Or even is this the name of the veterinarian that saw the animal, right? We might even have multiple name fields each for each of those. And without further information, it might not be immediately apparent. So we want to very explicitly say, hey, these are our assumptions, kind of like this is where the data's come from. This is what each column, each property in our data schema means. We want our data to be accurate. So that it can be things like quality control checks that can also be capturing, again, explicitly the information that dictates when something is accurate, right? If I say, oh, hey, these are the possible values that we expect for the reason for a checkup, and then you look into the data set and you see, hey, here's a value that didn't come from that, well, then that indicates that there is some sort of an issue, right? Perhaps the value was entered incorrectly. If I state, hey, data in this data set uh, is coming from our system that first got set up in 2022, right? So all the data should be there. And you go into the system and you look and you're saying, hey, this record here says 1980. This record here says 2020. Then that's something we can say, all right, this doesn't look accurate because we've defined what accuracy looks like. And then this last one, machine readable, right? Um, this this has gotten a lot more complex with the advent of LLMs and a lot more simple in other ways. But effectively, we want to define our fields that hold the semantics, our metadata that describes what the data is about in such a way that it is machine readable, right? That we're not just saying, hey, here's a long text field, like the README that I suggested before, that kind of lists everything out in paragraph form, but that we have our own structure that we use. The structure that I'm most familiar with and that I walk through here is RDF and a knowledge graph, but there are other ways of doing this with XML, with JSON, with tables, such that you have all your information in a way where it can kind of be understood by machines or by LLMs to help answer information. So when someone at your organization says, hey, give me all the data sets that are about animals at this veterinary clinic. The machine says, okay, I have a concept called animal. Here are all the data sets that I can see have been labeled with that concept animal, meaning that they have the concept animal, and I can return those to you instead of having to kind of search for, all right, I need to know the exact names of properties and columns and entities in order to find what you're looking for. Findability is often a big focus in the semantic world, but it is not the only focus. So I will go ahead and stop sharing at this point so that we can open this discussion up for questions. I think Bonnie had mentioned earlier, and sorry if I'm stepping on you a little here, Bonnie, but please put your questions in the chat and we will go through. And if we need, kind of we'll call on you for additional information.
Yeah, thanks for that, Ben. Yeah, that's all I was going to say. Go ahead and drop your questions. We will answer them as best we can. All right, looks like we've got one already. So Simrat here is asking, what kind of team is typically needed to get started with semantics?
Yeah, that's a great question. It is very dependent, I guess, on what the scope is of getting started, right? I think always you need to be working with people that are close to the data as possible. I think this is a concept that if anyone is familiar with data mesh, you'll see referenced really heavily, but who are the subject matter experts? And then who kind of models for the data, who works with kind of the tools that are owning it that can answer questions around quality, around how often data is updated, for example. You can also have, someone who is in the knowledge management field, such as myself or Bonnie, although people also kind of do this as an add-on to their jobs, depending on size of an organization. But you need those subject matter experts. You need your kind of technology expert that you're working with to say, okay, what is this about on a kind of conceptual level? How does this relevant to the business? Understanding what you need to capture from them. And of course, you need to be working with whoever is going to ultimately be using the semantics that you create, right? To say, all right, what is actually helpful for folks? Are people looking for definitions of data elements, or does it turn out that actually what people really need is labeling of data sets?
Nice. And it looks like we've got another question for you here. How does a team best decide the labels or names for the relationships? So if you want to take a stab at that.
Yeah, that's a good question. Can I ask Charles, is this relationships within a data set or between data sets?
Oh, good afternoon. It
Good
would
afternoon.
be it would be both actually. So my question really is around let's just say a cat is a part of the animal kingdom. But maybe a colleague of mine says, no, a cat is not part of the animal kingdom. It's a part of, I don't know what else. But, how do you determine kind of those, how do you, as a group, agree upon those relationships? Does that make sense? Because I could see there's many different ways to go. Like, Cincinnati Reds is a part of baseball. Cincinnati Reds is also a part of the city of Cincinnati. Baseball, Cincinnati Reds is also a part of American sport. But I guess you have to do all of those, or or you choose one. It just seems like you could go into, you could spend all day on relating one
Yeah.
term to a million things.
Yeah. No, that's a great example too, what the Cincinnati Reds is a part of. Because what we really want to avoid is semantically overloading this is a part of relationship, right? Where it has so many meanings that you look at it and you say, I have no idea ultimately what's being related here. I think that one way that I would suggest starting is actually, whenever possible, right? We don't want to take the whole afternoon arguing through and reinventing the wheel. A lot of semantic models have been created that are open sourced, right? That you can look at to say, well, how have different subject matter experts before me worked to create a model for understanding is a part of, for example. Again, I've most recently been working with Prov, for example, which is like a very basic model for understanding data lineage, where that has different functions of is a part of to say, all right, one piece of a data set is a part of another data set that came from an activity that had a particular source. So I think using open standards is a good beginner. And then also, again, if we go back to your is a part of example, we might want to specify more specifically to say, all right, Cincinnati Reds is a part of location, and then give the location, right? Or, gosh, you had some like good examples here. Cincinnati Reds is a part of sports teams in city, and then give the city, where the relationship itself says what is the object of this relationship going to be.
So kind of instead of is a part of, it would be is in Cincinnati, which is a city, like trying to, have a bit more variety in those is a blank relationships.
Yeah.
Got
And
it.
then also say looking to things like, excuse me, like the ISO taxonomy standard that typically have good rules already written for, hey, how should relationships between concepts be written, right? And kind of adopting those existing standards for your own.
Oh, that's a good one. Yeah. Can you explain more about the ISO standard if you have time?
Yeah, I don't remember the exact number, but there is,
Oh, that's okay.
unfortunately,
It's a
but
part
there,
of ISO standards.
yeah, this ISO
It's
standard, which is a
related
part of
to.
ISO standards, that is the source
Okay.
standard, right? Where the
Okay.
sources have a good number of associated relationships, such that this kind of has some good information already on writing relationships.
Okay, that's good to know. Thank you.
Yeah, I'll also, there's like a couple models that I will look to, things like if you're working in the financial services realm, I'll often look at the FIBO, or the Financial Industry Business Ontology, to see, hey, what can I borrow from this model that already has a lot of information on what relationship connects a person and their account, right? And then see, hey, does this label and definition make sense for my use case or not, right? Can I use this as is, or do I need to tweak it a little?
And the only other thing that I would want to add to that is before you even try to give labels to these relationships and any of that, to work with the team and whoever the end users are going to be and just try to settle what exactly are you designing for? What are the questions you need to answer? Like, for instance, would you ever need to answer, Cincinnati Reds has owner or practices at, and if you don't need any of those relationships, there's no point spending the time representing them. So I think part of it is identifying what kind of relationships you need to define, what kind of questions you need to answer, what kind of queries your end users will have, and then, no need to worry about developing the others. And it looks like Ben has gone ahead and dropped a link to that Prov ontology mentioned earlier. So thank you for that. Yeah, any follow-up questions, or does anyone else here have any other questions for Ben? We still have a bit of time.
Yeah,
Sorry, go ahead.
no, I'll let Emma go. She typed.
No, I like it though. We'll get to you. We'll get to you next. Don't worry. All right. So Emma here is asking, can you share an example of a project where semantic design directly impacted user engagement or satisfaction?
Yeah, so there's kind of a number of different ways of answering this. I'll give an example of what I found, what I thought was one of the most frustrating user situations that we helped deal with, where this was working with a kind of large, a very well-known bank within the US, I think is also multinational. They have a lot of data obviously related to working as a financial retail bank. Their issue was they had like dozens of different ways of describing the same data properties and data elements across data sets. So the last 6 digits of a credit card, for example, were a very common data element that they had like literally 10 different ways of referring to. And it was very difficult if you're someone working with their data sets, looking at two data sets, to be able to say, hey, is there any way of connecting these? Because you wouldn't know, hey, this column in data set A and this column in data set B, in fact, can be matched upon to aggregate, to join the two data sets together. So kind of just as like a simpler project, right? This wasn't necessarily a large effort, but they had already done the work to identify these are the, I think, 10 most common properties that our data sets are joined on for our data engineers to understand and make use of what data we have. And we did a simple model that had all 10 of those properties as well as like a small amount of additional supporting information. We captured, all right, what are the different ways that these 10 most common joins are referred to in this data catalog. And then we worked with the data catalog team to link all of these and to automatically like identify when someone's registering a data set to say, hey, this column looks like it's a phone number. Is it? If they say yes, then it's linked to this common phone number concept. So that you can now look for, all right, give me the data sets that have this phone number, that have the last 6 digits of a credit card, so I can see what other data sets I can join to for use. You can now look at a data set, and even if someone has not done a good job documenting what this data set is, which is, unfortunately pretty typical, you can still like say, okay, well, for these columns, which are oftentimes like the keys, the most important for identifying what each row is, we know, all right, these are customer account numbers that follow this particular customer account number standard versus another. So that's something where we had a really direct impact on just a wide range of, in this case, like mainly the engineers and analysts at the organization. The relationship of semantics to, okay, so Charles has another question. I should be reading these out loud for the recording. What?
You're doing my job. I meant to ask the questions. You just answer them.
Oh, you go for it, Bonnie.
So we have another question from Charles, and this is a really good one. I'm glad someone asked this. We're running out of time, but I think we can make sure we get through this. So what is the relationship of semantics to AI? So thinking about things like ChatGPT, intelligent agents like Microsoft Copilot, and so on. Can we hear a bit more about, how semantics plays into that and whether it's important?
Yeah, no, that's another great point. Just give me 1 second to take a sip. Semantics to AI. I guess there's probably a couple of relationships, right? I think that semantics is often something that you want as an input to your AI. I mean, there's the old saying is still true with LLMs and AI agents, right? That bad data in is bad data out. And although LLMs have shown a decently impressive capability to work with like some textual ambiguity, having semantics around like describing, hey, this is what each element of data set is context that is useful to an AI agent when answering questions. I actually have a project right now working with a team that is asking, hey, we have a larger graph for data lineage, right? Basically saying what data sets were used to create other data sets. that is the semantics that we're working on with them, right? It's a little bit more of an advanced use case, but it's a really important one for this group in being able to say, hey, if something is marked as privacy information in dataset A, what other datasets are affected in terms of like access requirements? And so we're looking at, well, this is something that we want to be an input to LLM agents that are being worked on at this company, and it is like a FANG company, so that they can use that as context when someone asks a question of, hey, where can I find this data element within a data set, right? Having that structured descriptive metadata is really strong for like enabling AI agents to know and make sense of what they're looking at, because they can't infer context that doesn't necessarily exist, right? If you're giving an AI agent a bunch of JSON files or tables that have little to no descriptive information, well, the AI might be able to say sometimes, hey, here are the actual like titles of the columns in here, but it won't necessarily be able to answer questions about which column should I look in for X type of information, right? Like what column should I look in to see aggregated access counts for the day?
I would also,
So that,
sorry, can I add a little point?
yeah,
Another thing that I would bring up where semantics is especially valuable is, because as Ben said, there's a lot of open source information, whether it's taxonomies and ontologies covering, major domains of expertise, like for the sciences, for healthcare and all of that. But when it comes to something very specific to an organization, especially if it's internal, if it's jargon, if it's specific products, if it's something that means something specific to your organization and wouldn't mean the same thing elsewhere, off-the-shelf LLMs or generative AI solutions aren't going to have quite as much context for that. So I would say semantics, whether that's a taxonomy, an ontology, data models that provide context for your organization's specific terms, specific products, specific processes, workflows, and all of that, that is really important because that can provide something that couldn't be scraped really from elsewhere. So that's the one area that I would add that it's especially important to have something custom tailored for your own org. And we are just over time. Oh, yeah. Go ahead. Finish it up.
the other thing I'd want to mention briefly without trying to get into technical details maybe is if anyone here is familiar with the concept graph rag, it is basically a way of using a graph data model to provide additional context to an LLM when it's answering a question, where say you ask the LLM, what is our forecast for 2025 in the North America region, right? The LLM goes to this graph data model. It says, okay, I see in this graph data model, there are things that exist called forecasts, that forecasts have times, and here are the documents that I need to look at to find this information, where you're giving extra context to boost the accuracy and lower the rate of things like hallucinations. And thank you, Bonnie, for pulling that out in the chat.
As a taxonomist, I'm overly obsessed with spelling out acronyms. I can't help it. Well, thank you so much, everyone, for joining. We are a bit over time, so I want to be thoughtful of everything else that you have to run and do, but thank you to everyone for joining. Thank you especially for those of you who brought some great questions. Thanks for listening in. If you found this helpful, please go ahead and share this with any of your colleagues. Again, we will be making a recording available shortly, and stick around, tune in next week. We will have more coming in this series where we'll be covering some different topics. And as always, go ahead and follow Enterprise Knowledge on LinkedIn. We'll keep sharing updates for additional webinars and other sources of thought leadership like our webinars, case studies, blogs, white papers, infographics, all of that good stuff. So thank you again for joining. Have a great rest of your Wednesday.
Thanks, everyone.